Hi everyone, let's solve today's daily challenge, that is single element in a sorted array. So in this question, we are given a sorted array consisting of only integers where every element appears exactly twice except for one element which appears exactly once. We have to return the single element that appears only once. So your solution must run in O login time and O of 1 space, right? So let's see, we are given a sorted array, and also we are already told in the question we have to do it in O of login time. So one thing that straight away comes in our mind is binary search, right? So yes, that is what we have to apply here. We can solve this question using binary search. Now let's see. Let's first so I hope the question is already like it's self-explaining. I don't have to explain a lot. Like you are given an array in which you have these numbers, let's say 3 and 3. So in this array, every number appears twice, right? And exactly twice. It's not even like that one appears 4 times or something. One appears only 2 times. Like whatever numbers are there, they are present exactly twice except for one integer which will be alone, right? It will be only a single integer, right? It will not have any other integer that will be equal to it. So we have to simply return this integer, right? So let's see. So we discussed that we can solve this question using binary search. Now how can we apply binary search here, right? So binary search, what do we do in binary search? Let's consider this array here only. 2 3 3 4 4 5 5, right? We have this array. So in binary search, what we do is we find some way in which we can reject either one half of the array or the other half of the array based on some condition, right? So let's see what condition we can have here. So if you observe carefully, you can see that if you consider any number inside of this array except for this these two last numbers, right? If you consider any elements, right? Let's say if we consider 1, right? And you check its left and right, if it appears, if it is present twice in the array, then we will either find it in the left or in the right, right? So here we can see it is present in left. Same goes for this particular 3, right? Either we can find this 3 in the left or the right. But for a singleton integer which does not have any other integer equal to it in the array, the left and the right will never be equal, right? So this is the base condition, right? So what we will do, we will calculate the mid and we will check if mid plus 1, right, is not equal to mid, and also if mid minus 1 is not equal to the value at mid. If these two conditions become true, that is the left and the right, they both are not equal to the mid that we have, then we have to return it, because this will be our answer, as only one such an integer, only one singleton integer appears in the array. So this is the base condition. Now let's see if we are not at such a mid, right? If we are at this particular 3, right, at a number which appears twice, then how do we decide where we have to move? Okay, so let's see. So let's consider an array in which we only have pairs of elements, right? So we have 1 1 2 2 and 3 3. So we have such an array, right? Let's also write their indexes 3 4 and 5. Now if you consider all the even indexes, right, if you consider all the even indexes, you will find one, like just after that particular index, right? 0 is an even index, right? So plus 1, that this even index, you will always find a number equal to whatever is present at the even index if you have all the pairs inside of the array, right? But if you introduce a singleton integer, let's say you let's say let's rub this 2, let's rub this 2, then what will happen? We will lose this property, right? We will lose this property. that we just saw, that if you see at 0, 1, up to here it is fine, but as soon as this 2 has been introduced, because it does not have any pair here, we are here, right? So it has disrupted the pattern that we found using the pairs, right? So how can we find out in which part of the array do we have to move? So wherever this disruption happens, right, wherever this disruption has happened, we have to move towards that particular part, right? So what do I mean by that? So what we have to do is we have to either reject the right half or the left half. So let's say we are at some mid, right, currently in the array. Let's say our mid was this, right? So up to here, right, up to this mid, this property is true, right? That means as it is not disrupted in the left side, we will have our answer on the right side of the array, right? Similarly, if we are whatever mid we are present at, if this property does not hold for this part, right, for the left part, that means a disruption has happened in the left part, so we will move towards the left part, right? So I hope this is clear to you, right? So we just have to find where disruption has happened, right? If we have found that the disruption, like by traversing the array, at whatever mid we are at, if the disruption has already happened, that means our answer is present on the left, right? Because let's say we are at this particular 3 inside of this array, right? And here you see this property does not hold true, that this is 0, this is 1, this is 2, this is 3, and this is 4. So it's an odd index, right? And so 3 should have been at 2 index, right? But because of this 2, our property does not hold. That means our answer is present on the left side, which is 2, right? It is present here. Similarly, if you see for the second test case, we will be getting our mids at this place, right? So you see, up to this point, our property holds, right? That is, if you take the even index and you check the next index, then you can find the same element, right? It holds for 3 3 and it also holds for 7 7. But right, so in the left part, right, before mid, the property holds. That means we have to move towards the right part. So now let's see how we will check, right? How using the mid only we will check if the property was disrupted or not. So what we will do, we will check what index we are at, right? So let's say here in this array, let's write the indexes. So it is 0, 1, 2, 3, 4, 5, 6, 7, 8. So our mid will be 4, right? That is this particular index. So if this is even, right? If the index that we are currently at, if this is even, how will we check if the property was disrupted? So we will check if after 4, right? After 4, we should find 3 at 5 index, right? Because to hold the property, if mid is even, then we should find mid plus 1 equal to this mid. But if you see it, they are not equal, right? They are not equal. That means property was disrupted, and in this case we have to move towards the left, right? Similarly, let's say after moving towards the left, we will actually be coming to this index. Let's consider another case, right? Let's say we had something like this, right? Now if you see 3 4 5 6, right? Now if you see 6 plus 0, that is 3, you will come here, right? This is an odd index. This is an odd index. To hold the property, you should find the value at mid minus 1, right? They should be equal, right? So they are equal here. So that means the property was not disrupted in the left. That means the answer lies in the right part. So then we will move towards the right parts. So that is all the observations, and using these observations we can solve this problem. So the very first thing is this base case, right? When we have to return the mid. Also there will be two edge cases. Let's say our singleton elements appear here, right? We have 1 2 2 3 3, right? Our singleton appear here, right? That is the at the very first index. Then we can simply check if the next index is equal to this or not. If it is not, then we can simply return this. Similarly, let's say if this case happens at the last index of the array, right? If it happens at the last index of the array, then what will happen? We will simply check the previous index, right? If they are equal. If they are not equal, then that means whatever is at the last index of the array, we have to return that. That is 3 is our answer in this case, right? So these are the two edge cases. These are the two edge cases. Okay, wait. These are the two edge cases, and here we have our base case. This is our base case, and this is our property, right? That you have to check mid, right? If it is even, then what should hold? Mid plus 1 should be equal, right? If they are not, that means the property was disrupted. And similarly, if this is odd, then mid minus 1 should be equal. If this is disrupted, then where do we have to move? Towards the left part of the array, right? So using these conditions, let's also code this out, right? So just like a normal binary search, first of all, let's take the size inside of this n variable. Then what we will declare? We will declare a low, which will be pointing to 0, and a high, which will be pointing to the last index, and a mid, right? So while low is less than equal to high, then first what we have to check? First, let's consider the edge cases. Also, there will be one more edge case, that is if num's size is 1, right? If there is only one element present, then that will be the answer. Let's also after this, let's check if n equal 1, then what do we have to return? We have to simply return whatever element we have inside this array, right? So that will be our answer. Now, otherwise what we have to do? We have to do binary search, and here what we will do? First, we will check if the singleton element is the first element or the last element. So we can simply return that. So we can check if okay, let's also calculate mid here, right? Mid will be equal to low plus high by 2, right? So we will check if mid is 0, right? If at any point mid becomes 0, so what we will check? We will check if mid is 0 and nums of mid plus 1 is not equal to nums of this particular mid. That means this is a singleton element, so we will return it, right? We will return nums of 0, we can say, right? Because this is the mid. Okay, otherwise the next condition will be that if mid becomes n minus 1, right, and nums of mid is not equal to nums of its previous element, right, then also the last element will be our answer, so we will return that. Now we have to check for the base case. If our singleton element is not here, we have to check our base case, that if, right, the left and the right of that particular value, right, if it does not if they are not equal to the mid, right, if any of these values are not equal to the mid, then we can say that this is the singleton element, right? Because only in the case of singleton elements, the left and right will be different, right? So we will add this condition: if nums of mid is not equal to nums of mid plus 1 and nums of mid is not equal to nums of mid minus 1. In this case, we can say whatever is at mid, that is our singleton element, so we will return that. Otherwise, we have to see in what part of the array we have to move, which is left or right, right? So we saw, we will check if mid is even or odd. It will be based upon that, right? So we will check. We'll check if mid modulo 2, if it is 0, right, that mid is even, right? So we saw, let's only consider when we have to move towards the left, right? So if this is even, right, if this is even, and so to disrupt the property at an even index, what should be the condition, right? So here, as you can see, let's say we are at this particular 3, right? Then if it is equal to the previous element, then the property has been disrupted, and then we have to move towards the left, right? So if mid modulo 2 is 0 and nums of mid even index, if it is equal nums of mid minus 1, then we have to move towards the left. Other condition is to move towards the left if let's put this inside of a bracket, right? So here we will check if mid modulo 2 is equal 1, right? And we will check if nums of, so if we are at a odd index, right? If we are at an odd index, let's say if we are at this particular index, so its next element, if it is equal, right, then we have the property was disrupted in the left side, so we have to move towards the left. So we will check if nums of mid is equal nums of mid plus 1, right? Then the property was disrupted and we have to move towards the left part, right? So we'll say to move towards the left part, we will say high is equal to mid minus 1, right? Otherwise we have to move towards the right part, that is low is equal to mid plus 1. And that is all we have to do. So after this, we'll simply return 0 because we have to return something. So let's quickly run this. Okay, so that is how we have to solve this question.